This is the code we ended up with at the end of the last course section, our practice project. A lot of code all in one file. And this is arguably not a super complex project. You can definitely write way more elaborate projects and applications, and you would end up with way more code. So putting it all into one file is probably not what you want to do. So what you want to do instead is you want to write modular code, which simply means you want to split your code across multiple files so that each file on its own stays manageable and maintainable, and you then simply import and export from into these files and make sure that therefore all these files are connected, but they're connected by TypeScript or by the browser or by some third-party build tool, and not by you by merging them all into one file during development. Now in this module, we'll have a look at two main options that help us with organizing our code in multiple files. And we'll not just learn about them in theory, but also in practice. We'll of course apply these different approaches and see how we can split our code. So what are our options when we want to split code into multiple files? Now actually we have three options for that. The first option would be to simply write multiple code files, multiple TypeScript files. TypeScript will then automatically compile all code files in the source directory and manually import the compiled JavaScript files into HTML. That is an option, and for some projects this might be just right, but you would have to manage all these imports manually, which can be cumbersome and error prone. And when using certain TypeScript features, you also give up type support if some type is defined in file A and you use it in file B, and TypeScript doesn't know about this connection. That's why this is not really a great option for bigger projects. Instead, for bigger projects, we have two main options. We have namespaces and file bundling, for example. Now, namespaces is a TypeScript feature, a syntax feature. You can add special code to your code to use this feature, and it allows you to basically group code together below a namespace and then import namespaces into other files. So you can have a namespace per file, for example, import another file into yet another file and tap into that namespace which lives in another file from that importing file. And we'll see that in practice in case that's not entirely clear. TypeScript does not only support that, it also bundles the files together into one file so that you in the end write code in multiple files which are compiled, but they are then imported into each other so that you have less imports to manage and you don't need to manually manage different imports in an HTML file. Now, an alternative to namespaces, and arguably the more important and modern alternative, is to use ES6 imports and exports, also known as ES6 modules. Because it turns out that totally detached from TypeScript, modern JavaScript has a solution for this problem as well, because you have this problem not just in TypeScript projects, but in any bigger JavaScript project. Modern JavaScript out of the box supports import and export statements, which allows you to state which file depends on which other file. And then you have all these individual files, but you don't need to manage imports manually. Instead, modern browsers do that. They understand it and automatically download and run files another file depends on. You use the import-export syntax for that, and TypeScript also supports this. So therefore, you can use it in TypeScript without any issues. You compile per file, but you only need one script import because, as I just mentioned, modern browsers know how to then fetch all other dependencies. And you'll also see that in action in this course section here. Now, one important note here, with that we technically will end up with multiple files still, and whilst we won't have to manage the imports manually, the script imports, we still have some disadvantages because of that. Because every file you're depending on needs to be downloaded separately, which means more HTTP requests and so on. And therefore you can bundle files together to work on multiple files during development, but ship a single file for production. But you need third-party tools for that, for example, Webpack. And I will show you how that works as well, but in a separate section where we will have a look at Webpack and TypeScript and why we use it and how we use it. So for now, let's use these two approaches in their basic form, and let's see how we can improve our code by splitting it across multiple files. I want to start with the namespace feature. Now, to show you how it works, I will grab these two interfaces here, the drag and drop interfaces, cut them from app.ts and add a new file, drag drop interfaces.ts, for example. Now we can paste it in there, and now to use namespaces, all we have to do is we have to add the keyword namespace and then curly braces. Now we also have to give this namespace a name, and here I'll name it DD interfaces for drag and drop. The name is up to you though. Now this here is a TypeScript feature, not a JavaScript feature. It is not compiled to vanilla JavaScript because there is no direct equivalent for it. Instead, TypeScript will basically compile it to an object, you could say, to an object where the things you will put into the namespace then are stored on properties. But you won't have to worry about that because all the resolving of access to these properties and that everything works will be taken care of by TypeScript. So now we can move these interfaces into the namespace, and with that, we're almost done. Now we have one problem, however. These interfaces are now only available in this namespace. By the way, you cannot just put interfaces into a namespace. You can put anything in there. Classes, constants, whatever you want. Whatever you want can be put in a namespace. So basically, you can wrap a namespace around any code you have. But the problem we have is that these features, these interfaces here, are now only available inside of that namespace. Now, as you see, we have nothing else in there. Now, of course, we could bring the code that depends on them back into this namespace, but then again, we would bloat this because turns out we have quite long classes that depends on these interfaces, right? We have the project list class and the project item class. They depend on these interfaces. So there would be a lot we have to add to that namespace. Therefore, what you can do is you can add the export keyword in front of an interface to export a feature from a namespace. Now, what this means is that now these interfaces are available inside of this namespace, but also outside of this file. You will see how this works in a second, but with that we make this interface or whatever we are exporting, this is not restricted to interfaces of course, available outside of this file as well. If we then basically import or use that namespace. And of course, again, you cannot just export interfaces in a namespace, but anything. Now with that, the question just is, how do we import this namespace now back into app.ts? And for that, TypeScript has a special syntax you can use. Let's go back to the top of app.ts, and now here you add free /. Important, free, not just two. Because this is actually not a normal comment, what we're creating now. This will actually be syntax picked up by TypeScript. A special comment, you could say, TypeScript understands if it starts with free slashes. There, you write a self-closing XML tag, so opening angle bracket, then / closing angle bracket, and in there, reference path equals, and then here the name of the file you want to import. In my case here, drag drop interfaces.ts. Now this is understood and picked up by TypeScript because, as I mentioned, with the free starting slashes, it's a special syntax TypeScript understands, just as it understands this reference thing. This is not vanilla JavaScript. Vanilla JavaScript does not know this, and this is not what it will look like once it is compiled. Now, what does this achieve though? This achieves that now this namespace, DD interfaces, is available in app.ts. However, if you scroll down, you see my editor still complains. And if we try to save this, we also get compilation errors. So it doesn't seem to be available. The draggable interface doesn't seem to be available here. Well, there is a special thing about namespaces. You can use them to split your code. And remember when I said earlier that what you have in a namespace can be used from anywhere in that namespace? Well, it turns out you can split namespaces across multiple files by exporting things in a namespace and then using this special import syntax, but You then have to put the things that want to use something from that imported namespace or from that imported file into the same namespace. Hence, maybe DD interfaces is not the best name. Maybe we just name this app. Now, if we name this app here, we can go to app.ts and create a namespace of the same name here, namespace app. And now, for the moment, let's put everything here into that namespace. And now you see the error is gone. There are no red dots on the right. However, if I save that, I still get errors here. For example, that finished project list is not used. Well, that is correct. I am not using that. I am not needing it either, so we can simply remove these constants here. With that, if we save this, now it compiles without errors. The question just is, what's the result of this compilation? Do we have 1 or 2 files now? Well, let's have a look at the dist folder. And there you see, you got an app.js file, and then some code here, and a drag and drop interface.js file. So we got 2 files as a result. Now, the drag and drop interface file actually is pretty empty because you learned that interfaces are basically not compiled to anything. There is no JavaScript equivalent for an interface. It's a pure TypeScript feature. So we can import it with the TypeScript syntax here to use it and get all the type improvements we learned, but in production, it doesn't matter if it's in a separate file or not. So of course the question is, what if we now put something that does exist in production, that does exist in JavaScript as well, into a separate file? For example, this enum and the project class here. I'll grab both, create a new file, project-model.ts, and put my project status enum and project class in there. Now, just as before, we can add a namespace here. The name has to be app, so it has to be the namespace where we then also want to use it. And we have to export these features in there so that we can use them in other files in the same namespace, but in other files as well. Now, back in app.ts, we have to import that second file. So I'll duplicate this import and also import project-model.ts. If I save that, it now is compiled and we see a project model JavaScript file. And in there, we see some code. The question is, does our application now work? For that, let's reload it. Let's try adding a project here. And you see, we get an error. Cannot read property active of undefined. The reason for that simply is that our files are compiled standalone. Namespaces exist in TypeScript world. As I said, there is no JavaScript equivalence for it. So the problem we have here is that in TypeScript world, everything is great because TypeScript is able to find all the things we need. For example, when I say project here, when I reference the project type here on the project state class, this project type, this project class, is defined in the project model. Now, TypeScript does not complain during compilation because we import that model. But import here really just means we tell TypeScript where to find that type. Once it is compiled to JavaScript, this connection is basically destroyed. So in JavaScript code, when this executes, and when we then try to create a new project by instantiating project, JavaScript doesn't find this project class or constructor function. So we have to make sure we carry over this connection. And for that, we can go to the tsconfig and there set this out file option. We can comment this in, and the idea behind the out file is that you tell TypeScript that it should concatenate namespaces, so these references which it has during compilation, into one single JavaScript file, instead of compiling multiple JavaScript files. So here for out file, we can say we want to have a file in the dist folder, which we name maybe bundle.js. And if we do that and save that, we'll actually get an error here. We'll get an error that only AMD and system modules are supported alongside out file. Now, we don't need to understand everything here. There basically are different ways of loading or of bundling different JavaScript files into one for historic reasons and how this all developed. And you can learn more about these different bundle types in an attached resource if you want to. You don't need to though. So basically what we need to do here is we need to set module, which is already highlighted as an error here, not to common.js, but to AMD, for example. If we do that, it compiles without issues, even though it still complains here, but it didn't pick up that I changed it. And now what happens is actually that there is a new bundle.js file in dist. If I remove all JavaScript files in the dist folder and I restart my tsc-v process, so the compiler, you see only that bundle.js file is generated. This file will hold all our code in the compiled and translated version, and therefore now in index.html, we just have to import bundle.js here instead of app.js. And if we do so, and we reload here, we have a working application again, where we can use drag and drop and everything, because now it's all in one file, but only in the final result. During development, we have these namespaces here, which is one step in the right direction because this already is a bit more manageable. Now let's split this into even more files before we then have a look at the other splitting option, ES modules. So we got started with namespaces. Let's continue on that route and let's split it into more files. For that here, the project state management, we could put that into a separate file as well. So I'll grab everything, including this creation of the project state instance here, cut it from the app.ts file and create a new file, project state.ts. Move that in there and just as before, put it into a namespace. Namespace app, name is important, it has to be app because that's where the rest of our code is in. Put it all in there, and now important, export what you need outside of this file as well, which in this case is the project state class. We need that in the rest of our application, and also this constant down there. We need to export this as well. You don't need to export the listener here, and also not that state, because both things are only used in this file and therefore don't need to be exported. Now we have to import our project state.ts file. So in app.ts, time for another import up there. Project-state, just like that. If we save that, it should compile without errors. Now I will continue, and the validation part here could go into a separate file as well. So I'll grab all of this, create a new file, validation.ts, add the namespace app here, put my validation logic in there, and export the validatable interface and also the validate function here, of course. And then back in app.ts, you know how it is. We go back here to the top and add an import to validation.ts. Now the decorator also can be moved into a separate file, autobind-decorator.ts, for example. Again, add the namespace with the name app to it, put the function in there and export it, of course, to make it available outside of this file as well. And then here in app.ts, time for another import, where I import autobind-decorator.ts. Now we got more things to export. We got our component and then all these classes. I want to have each class in a separate file so that each file is relatively small and easy to manage. Now we're getting into a new problem here though. We add more and more files on the same level, and for now I'm using the dash thing here to provide some hint or help on what's in the file. Autobind-decorator shows us that there's probably a decorator in there. Here we probably have interfaces, here a model, and so on. Now, if you only have 3 or 4 files, that is perfectly fine, but if you have more files, you end up with a very hard to understand folder structure here. So what I like to do is I want to create subfolders. I'll add a decorators subfolder, move my autobind decorator in there, and rename it to just autobind, because it's already in the decorators folder. Of course, there's a decorator in there. Then I'll add my models folder, and actually here I'll move both drag and drop interfaces and project model in there, simply because I think the drag and drop interfaces all in the end are just definitions of how draggable and droppable classes should look like, just as the project model is the definition of how a project class should look like or how a project object should look like. So I'll name this drag and drop and this here just project, and then here I'll add a util folder for utility and add my validation in there, and then a state folder and add project state to that. Here I will keep the name project-state just to avoid confusion with this project.ts file here. Technically that would not be a problem, but I want to also make it clear here in this course so that you have an easier time seeing in which file I'm working. You could definitely rename this to just project.ts here if you wanted to. Now with that refactoring and these subfolders, of course our imports here are broken, so we should fix them. Drag and drop interfaces is found in the models folder and now is named just drag drop ts. And the project model also is found in the models folder and is now just named project ts. Project state is found in the state folder, validation is found in the util folder, and autobind decorator is found in decorators and is just named autobind. With that, if we save that, it compiles without errors, and now we have a more manageable and readable folder structure, I would argue. With that, let's continue. We're not done. We have our component here. Now for that, I'll add a components subfolder, and in there, I want to have my base-component.ts file, and then my project item.ts file, my project list.ts file, and also the project input.ts file. Of course, you can always organize this differently, but I think this keeps the related files together. So we can grab this abstract component base class here, cut it from app.ts and move it into base component like this. And of course, also just as before, add it into a namespace with the name app. And then move it into this namespace. Of course, also just as before, we need to export it so that we can use it in another file. That other file, however, will not be app.ts because the files or the classes where I use the component will also be moved. The project item class here, for example, I'll grab that and move it into project item.ts. To be precise, in there, I'll also add a namespace app and move it into the namespace app in there, and then export this class as well. Now important, this relies on component, and therefore if I now save this, we would get an error that component isn't found in the end. So here we again need to add this import where we have reference path equals, and then here it's base component ts. This is always a relative import here, so since this is in the same folder, we don't have to say components / here because we don't need to go into the components folder first. This file, the project item file, is already in the components folder. So relative from this file, base component is imported just by using its name here. So now the project item is here. Now, of course, in app.ts, we also got the project list. Let's grab that, move it to the project list.ts file here, and there into a namespace app, and then also here the project input. Let's grab this, cut it from here, from the namespace app in the app.ts file, and move it into the project input.ts file, and there into a app namespace. Now important, just as before, export this class here, project item, and also project list, of course, all needs to be exported. And with that, we get a bunch of errors because, of course, still there are missing imports. In app.ts, we should import all these components now. So here we should import project input.ts, project list.ts, and then save this. Now, of course, it still crashes because we got more things that are missing. In project input, we are using component just as we are in project list. So just as we did it in project item, we need to add that import of base component in the project input.ts file and also in the project list.ts file. With that, it compiles without errors, and let's see if it also works. If we reload here and I add this, is draggable and droppable, and that all seems to work just as it should. And now we split this across multiple files. We still get one file in the end, but when we work on our code, it's now much more manageable because we have smaller, focused files where we can quickly find what we're looking for and where we don't have to scroll through a huge file to find the place we want to work on next. Now, one important note, by the way, you might be wondering why autobind works here in project list, even though I didn't add an import to the autobind decorator. Well, because in app.ts I have all these imports. Now, actually, if I remove these imports there, which would be correct, because in here I technically only use the project input, project list, and so on, we'll have a problem. You see, if this reloads, we have an error here, even though we get no compilation error, unfortunately, but we get a runtime error. So we need to make sure we import everything we use in a file into that file to be safe. Technically, we can import everything in app.ts, and since project input and project list, which for example use the autobind decorator, come later, the autobind decorator will be available when they need it. But this is not the cleanest possible way. If you instead import everything a file needs from inside that file, you have the guarantee that this file will have it available when it needs it, and you're not relying on some global file which imports everything, where you then might remove an import and suddenly everything breaks. So what's the solution here? Well, let's go back to the files and import what they need. For example, project input does not just need the base component, it also needs the validation logic and autobind. So in here, I will import, by going up one level with 2 dots, from decorators, the autobind decorator, whoops, like this, and from util, the validation TS file. That is definitely needed in this file here. I also need the project state in here. So I will import /state project state TS. And I will grab these imports and go to project item. And there I don't need the project state and validation, so we can remove that, but we will need the autobind decorator. We also need the draggable interface and the project model. So we'll also go to the models folder here and import project TS and drag drop TS. In project list, we won't need validation, but I do need project state and autobind. And in addition, from the models folder, I need the project TS file and the drag drop TS file. With that, this saves and compiles, and now this also works again, as you see. Now we got no runtime errors, because now we got all these imports back in the files. So this is the proper way of doing it. Every file specifies what it needs, and we can split our code and still end up with one file, so we get the best of both worlds, we could say. Yet, this is not necessarily the best possible way of doing it. Namespaces are pretty nice, but they're not necessarily perfect. We saw one problem in the last lecture where I manually added all dependencies to each file. When I remove drag and drop from project list TS, for example, it still compiles without errors. This is not ideal. Now, it might or might not work depending on whether some other file imports the drag drop model, which I in the end need here, which here would be the case. So technically, even after removing this, it works here. But this is not great. This is pretty dangerous. If we rely on the fact that some file will handle it for us, well, if we then delete or change that file which saved our ass, we suddenly change something totally unrelated and our app stops working. We definitely don't want that. So it would be nice if we had imports and exports that clearly state what we import from which file. And if we need something here, drag target for example, and we're not importing it explicitly, we get an error. That is basically what we want. And we get this behavior with ES6 modules. Now, ES6 modules also exist outside of the TypeScript world. Modern browsers support them natively, where the browser will then basically download all dependencies of a file when it executes. But TypeScript also supports them and then gets the additional type support when we use them. Now, how do ES6 modules work? Let's again start with drag and drop. Let's remove that namespace thing, which is a pure TypeScript feature. Let's keep the export keyword though. The export keyword is not just there to work with namespaces, it's actually a default JavaScript syntax which is also supported by TypeScript. It means that you export this interface, and this one here as well, from this file, and you can then import it into another file. In our case here, we need it in the project item and project list files. Now let's start with the project item. To import something from ES module, so with that ES module syntax, you specify import at the top of the file or near the top of the file before you start writing any actual code. Import from, and then you point at that file with a relative path from the file on in which you are importing. So in this case, we need to go up one level with 2 dots and a slash so that we are in the source folder. And then we need to go here to the models folder and import drag and drop. Now important, add .js here because you need to import as if this already were compiled, because this will be taken over into vanilla JavaScript and then it should look for JavaScript there, so for JavaScript files. So .js needs to be added. Now you import something from there, and for that you add curly braces between which you specify what you want to import from that file. And there I already get auto-completion. I want to import draggable. Now draggable is available here, and TypeScript sees that this is now available and is happy. Now we need to convert everything so that I can show this at runtime. So let's get rid of the namespace here as well, of the closing curly brace as well. And for example here, now we get what we want. We get errors. We get component, error, project. This is all missing. So let's export and import all these things. For example, in base component, get rid of the namespace, keep the export keyword as you learned, get rid of the closing curly brace and reformat. In project input, we can also get rid of the namespace. And also of the references here, you can actually delete all reference imports you have anywhere. Get rid of all the namespace curly braces. Project list, get rid of the namespace and the references, get rid of the closing curly brace down there. In decorators, get rid of the namespace and the closing curly brace. In drag and drop, we already got rid of it. Project, get rid of the namespace and the closing curly brace. Project state, unsurprisingly, get rid of the namespace and the closing curly brace. Here we actually were relying on project being imported by some other file. I didn't have references to it here, so that was that dangerous behavior I was talking about. This could have failed if we wouldn't import or if we wouldn't reference our project part in the namespace in some other file. So that definitely was not ideal. But with that, let's continue our refactoring. In validation here, get rid of the namespace here and all of the closing curly brace here at the bottom. And last but not least, in AppTS, get rid of these imports and of the namespace. So now we got the errors everywhere, but now we can start over. Now let's maybe start over in the base component. This is looking good. It's not complaining. It seems to have everything it wants. Project input, well, it is complaining. For example, there we need the component. So let's add an import at the top, and let's import component from /base component. This is how you import relatively if something is in the same folder. / at the beginning, then the file name, and then also important .js. Don't forget the .js at the end. Now we also need the validatable interface here and the validate method, autobind, and project state. So let's import all these things. Let's import from go up one level, then util, then validation.js. Let's import from that file validatable and the validate function, and import autobind from going up one level, decorators, autobind.js. And last but not least, the project state. Let's import from going up one level, state project state.js. From there, we can import the project state constant that we export there. Now, these are all the imports we need here to make this file work. So let's move on to project item now. In there, we need autobind, we need component, we need the project model. So let's add all these things. Let's, for example, import the project model from /models project.js. Let's also add component, which lives in the same folder. So import /base component.js. And autobind. Let's import autobind from /decorators autobind.js. And now this file here also has everything it needs. Now let's move on to project list. Here in project lists, we also need the component and so on. So we'll actually copy that over here from project item, add it to project list TS, but we don't need draggable here, but drag target instead. So let's import that. And in addition, we need the project state, the project status. Yeah, these are the things we need. And also the project item class. So from the project model file, we can also import project status. You can import multiple exported things from one and the same file by simply separating them with a comma between these curly braces, just as you're seeing it here. We also import the project state constant from the state folder, project state.js, and also import, last but not least, here at the very bottom we need it, the project item class. So import project item from /project item.js. So let's move on. Autobind is fine. Project state is complaining. There we need the project model. So at the top, let's import project from, going up one level, models project.js. We also are using project status in here, so let's import that from that same file. And with that, last but not least, we got the app.ts file. There we need to import project input from /components project input.js and the project list from project list.js. If we now save this, it should compile without errors, and now we are using ES6 modules to organize our imports and exports. If we have a look at the browser though, we get an error. Now the reason for that is that if we check the dist folder, we get our bundle.js file, right? Now we need to switch to tsconfig again. For one here, we shouldn't use AMD now, but instead ES2015. That is basically the code word for ES6, which was the ECMAScript version that introduced ES modules. So we're basically telling TypeScript, don't transform our imports to anything, keep them as they are. Modern browsers will understand it. So that's important. Also make sure you have a target of ES6 or higher here. You now also should comment out the out file again, because that's not supported with ES modules. And with that, what you get in the dist folder is basically a replication of your source folder, but with JavaScript files. So now we also need to go back to the index.html file and import app.js again, because we got an app.js file in the dist folder now. And again, this app.js file will have your import statements in there, because as I mentioned, this is supported by JavaScript, by modern JavaScript engines in modern browsers, and the browser will resolve these imports for you therefore. So if we now reload this, we still get an error. Cannot use import statement outside a module. Well, modern browsers support this syntax, but you have to tell them that you want to use it. And you do tell them by removing the fur here, and instead on the script tag, where you import a file which has these import statements, you use type equals module. If you now save this, you see this works, and now if we add something here, we get the working application again. Now if you inspect the network tab, by the way, you will see that if you reload, there are a bunch of network requests going on. If I zoom out a bit, we can see it better. All our JavaScript files are requested here. They are requested automatically by the browser when it encounters our import. So it starts with app.js, then it sees the import to project input.js here, and hence of course the next request goes to project input. It also does the same for project list. Now in project input, for example, it would see an import from base component.js, which is why it also imports base component.js. So that's done by the browser here. We take advantage of it, and now we have another way of splitting our files, but with the additional advantage that we clearly state what we need from each file. And if we omit an import, TypeScript yells at us, which it didn't do with the previous approach, which is why this approach is actually my recommendation and why it is the de facto standard way of importing and exporting. Now, if you've worked with TypeScript before in other projects, let's say in an Angular project, you might also be used to not having to specify a file extension here. Well, we'll also be able to omit that once we add Webpack and a build tool. As long as we don't have that and we rely on the browser to import our files, you need to add that extra extension. So we're using ES modules. Turns out there are some variations of that export and import syntax, which you should be aware of. For example, you can bundle imports. Let's say here in project input, where I'm importing two things from the validation file here, you might want to group that all into one object where you then can call dot validatable and dot validate, so that you don't have to call validate like this. Maybe you want to call it like this, but if you had, let's say, a function of the same name in here or anything like that, and you want to avoid a name clash, or you want to make it clear that this belongs to some kind of package, you could group that. To group imports, you don't import them like this with the curly braces, but instead you use a star here, which means import everything from that file, as, and then any alias of your choice, for example, validation. Now you have to go to the places where you use something from that file and use it like an object, validation.validatable. So everything which is exported in that file, which you now group under this name here, is accessed through the dot notation. So validation.validatable all the way. And then also down there where we have the validate function, it's of course validation.validate, validation.validate, and validation.validate. And with that you will see, well, validation works. So grouping is one thing you can do. That alias thing here is also something you can do in general. You're not liking auto-bind like this. You want to have a capital character at the beginning? Well, you can simply assign an alias with the as keyword here. Inside of the curly braces, you can use it as well. Then you rename this import and only this import. You don't rename it in the original file, of course. It's only imported under a different name in this file here. So now instead of using auto-bind with a lowercase a, here we now have to use our alias name with the uppercase a. So that can be another nice feature to avoid name clashes if you had another thing named autobind with a lowercase a in the same file, for example. You can also work with default exports. If you have a file which only exports one thing, let's say base component. Actually, we have a lot of files that only export one thing. But let's say here in this file, we don't want to export it like this, a so-called named export, because we import it by name here in the curly braces. We need to use the exact name we used here. If you don't want to do that, you simply add another keyword, default. And this tells JavaScript that this is the main, well, the default export of this file. You could still have other named exports here that would be allowed. Whoops, for example, a constant here, that would be allowed. You can have named and default exports mixed in the same file. But if you use a default export, you can only have one default export per file. So here I have my default export, and now in the files where I import it, you don't import it by name. You can only import named exports by name. For example, that something constant I added. Instead, you import your default simply by choosing any name of your choice now, which doesn't have to match the name you used in the exported file, so you don't have to use component now. You could use just CMP, for example, here now, and import it like this, without curly braces. There also is no star, so I'm not importing everything. I'm just importing the default. Therefore, this is only available if the file you're importing from has a default export, because this tells JavaScript, hey, I want to use the default export of that file. And then here I can name this CMP, of course, or I have to use CMP, of course, now. Component is not allowed anymore because I'm not importing it by that name. Of course, we now also need to tweak this in project item and project list. We use the default export. I will stick to component here, but you don't have to, as I just showed. You could use any name you want here, but for simplicity, I will use component here. Default exports can be nice if you only have one thing per file. I personally prefer named exports though, because you get auto completion, you enforce a clear naming pattern if another developer imports your class or your exported thing, he has to use your name, which typically is good because it allows you to enforce certain naming conventions across a team or organization. And therefore, I personally like named exports, but of course, you should be aware of the default export as well, which you can use like that. Now, besides these different import and export syntaxes, which are good to know, there is one other thing which you have to understand and know. In project state, we're not just exporting a class or an interface as we're doing it in all the other files, but we're actually exporting a constant, project state. Now, the thing is, we're importing this constant in multiple other files. We're importing it in the project list TS file, and we're also importing it in the project input TS file. So we import from the same file multiple times. The question is, does this code in this file, namely the creation of this constant here, does this run once or twice, or how often does it run? Once per import statement or once for the entire app? Well, turns out it runs once when the file is imported for the first time by any other file. If another file then imports that same file again, it does not run again. We can also validate this by adding a console log statement here. Running. We'll see this only will get printed once, even though we're importing project state TS, both here in the project list TS file and in the project input TS file. Still, this will only be printed to the console once. You see it here, running. It will never be printed a second time, no matter what we do. So, this only runs once. This is how it behaves, and this is just something you have to know so that you can plan your app appropriately. And that's it for modules. Now, using modules is a super useful and important feature because it allows you to write more maintainable and manageable code. Having it all in one file is a mess and really not an option for anything but very tiny projects. Using either namespaces or ES modules is therefore a way better alternative, since it makes sure that every file on its own is relatively small and therefore stays manageable, and still you end up with that entire big application you want to have in the end. Now, when it comes to these two approaches, namespaces and ES modules, the clear recommendation is ES modules, because you get that extra type safety and you ensure that every file has to clearly specify what it wants. With namespaces, it was enough if one file imported something that another file also needs. The downside is if that one file which imported the thing is removed, that other file also breaks without you noticing, at least without you noticing before you run the code. So therefore, use ES modules, use namespaces in smaller projects, or if for some reason you can't use ES modules and you can't use another bundler which would translate such modules to non-module code, which also works in older browsers. But other than that, really use modules, ES modules. And what I just said is important. These modules here right now, the way we use them, only work in modern browsers, because we rely on the browser to basically import all these files, right? Now, of course, we want to build applications with TypeScript that also run in older browsers, Internet Explorer 9, for example. There, this would not be supported. This syntax is not supported there, so the app would not run there. We might also be using some other features that are not supported there, but mainly this here is not supported in all browsers. So to make that work in all browsers, we can use a bundling tool. We can use Webpack, for example, to bundle that together into one JavaScript file, so that during development we have this multi-file, strong typing experience, but when we ship our code, we actually have one file only. Another advantage of shipping one file instead of all these files we have here is that we also ensure that the browser doesn't have to download that many files. Because every file that has to be downloaded is an extra round trip. In the network tab of the DevTools, you can actually see that. There you see this waterfall chart, and you see this little white box at the beginning of every block. This is basically the setup time it takes to set up the HTTP request. So even though the files we are downloading are very small, as you can tell, this still takes some time because of all that redundant extra setup for every HTTP request. So doing less requests is a good idea anyways, regardless of browser support. So for these two reasons, browser support and less requests, we'll have a look at bundling with Webpack in the next course section. In the previous modules, we worked on a project, and there we either had all our code in one file, which made it hard to manage, or we actually split it into multiple files, either by using namespaces or by using these ES6 modules. But when using ES6 modules, whilst our code was more manageable, we actually had another disadvantage, into which I'll dive again in this module again. In this module, we'll not also have a look at that disadvantage again. More importantly, we'll have a look at a solution, Webpack. So in this module, you will learn what exactly Webpack is, and of course then we'll also use it to get a setup, a project setup, which gives us the best of all worlds actually, where we can write code, split up into multiple files without that disadvantage, and which we'll have a look at now. So which disadvantage do we have? This is the project we worked on, split up into multiple files using these ES6 module imports here. Now, let's actually build this project, and for that, as we did it before, we can run npm start to bring up that light server, and of course, very important, in a new tab, also run tsc-w to start up TypeScript compilation in watch mode. This gives us our project, and if we now open the network tab in the browser developer tools and we reload this file, we will see the disadvantage we have here, or the problem we have with this setup. We see a bunch of HTTP requests. Now you can ignore the last ones here, these are coming from our development server, but all these other requests here to app.js, project input.js, project list.js, base component.js, and so on, that's the problem. You'll notice that all these files are not that large, they're relatively small. So that of course is fine, but we have a lot of HTTP requests here. Now what's the problem with that? The problem with that can be seen if we have a look at that waterfall here on the right. Every HTTP request that needs to be made of course takes a little time. It takes time to download the files, but since they're not that big, that's not an issue. But every HTTP request has like a base overhead, a base duration it always takes. This little box you see in front of these graphs here, that's in the end the time it requires the browser to set up that request and send it. So whilst the actual downloading of the file might be relatively fast, setting up the request, doing the work on the server which serves the file and so on, that all takes some time. And now here we have a very fast setup because it's all happening on our machine. We got a local development server after all. If you deploy that to the web, having that many requests can really introduce a lot of latency and slow down your project just because of the sheer amount of HTTP requests made. So if we can find a solution to reduce that amount of HTTP requests, that would be amazing. And that's where Webpack comes into play. You can go to webpack.js.org to learn more about it. In the end, Webpack is a tool that will help us bundle our files together. And I can really recommend their extensive and comprehensive documentation you find on their page if you want to learn all about Webpack. In this course, we'll use some selected features that help us with TypeScript. So what exactly is Webpack? It's a bundling and you could say build orchestration tool. It's a tool that helps us reduce the amount of HTTP requests by bundling code together so that we can write code split up across multiple files, but Webpack then takes all these files and bundles them together. And in addition, Webpack is capable of doing more. It will also optimize our code, and it also allows us to add more build steps, more build tools, for example, to help us with CSS files and so on. That's not what we'll have a look at in this module though, because I want to focus on Webpack and TypeScript. So let's first of all have a look at our normal setup where we don't use Webpack. There we have multiple TypeScript files, but if we then use these imports, we get multiple HTTP requests, which is not that great for the reasons I mentioned. In addition, a topic I haven't had a look at before is we also very likely have unoptimized code, which means it's not as small as possible. We can certainly optimize code more by shortening function names and so on. And of course, we want a tool that does this automatically so that we don't have to manually work with unreadable code. We want to write perfectly readable code as a developer, but it would be great if we had a tool that then shortens this code and really makes it as small as possible, uses as short as possible variable and function names so that we ship as little code as possible. Because less code means that users can download it faster, which means our application can start up faster on other machines. And in addition, in our current setup, we have this extra development server, Light server, which is an extra package installed, which we have to spin up. It would be a little bonus, a nice bonus, if we had one command and that would do everything. Build our project, but also spin up such a server, which automatically reloads our website whenever we change a file in our project. Well, and that's where Webpack can help us. It bundles our code so that we have less imports. Instead, we have some, code bundles that we ship. It helps us optimize our code, minify it, as it's called, so that we ship less code and our users have less code to download. And we can also easily add more build steps if we want to. We can add such a development server, but we can also do many other things if we really want to, and the official Webpack docs are the place to go if you want to learn all about it. With that, let's see an example setup in our project and let's learn how we could use Webpack there. So back in our project, if you want to use Webpack there, I will first of all quit my compilation and that current development server and instead make sure we can use Webpack there. Now, since this is already a file with a package.json file, we can use npm to install more dependencies into this project. So simply more third-party libraries we need in this project. And here I don't mean third-party libraries which provide us certain functionalities we use in our code, but instead third-party libraries that help us set up a project workflow and configuration that makes development very efficient for us. We do this with npm install --save-dev to indicate that it's a development-only dependency, and then Webpack Webpack-CLI, Webpack-dev-server, TypeScript, and TS-loader. So that's a bunch of packages, and I will say what they do in a second. So let's first of all hit enter and make sure these are now all getting installed into our project here. And thereafter, we'll have a look at each package and see why we installed it. So let's wait for this to finish. So it did finish installing for me here. And now with that, let's analyze what we installed. In package.json, the new dev dependencies section, or it already existed, but now we have a lot of new packages there, I should say. These packages were added. Now, what do all these packages do? Let's start with Webpack. Webpack is the tool I just talked about. It's the heart of this entire setup we're now going to create. It is a tool that allows us to plug in certain functionalities to bundle our code and also to transform our code. And that transform our code part is important. We're having a TypeScript project here, right? Now, of course, we could certainly use Webpack to then bundle together all the JavaScript output, but it would be even nicer if Webpack would do both. Transform our TypeScript code to JavaScript and then actually emit a bundled JavaScript file. And Webpack is able to do that, thankfully. We need the Webpack CLI to run Webpack commands in our project, and the Webpack dev server to have that built-in development server which starts Webpack under the hood, which watches our files for changes, automatically triggers Webpack to recompile when something changes, and which then also serves our page. And then we got TypeScript and the TypeScript loader, the TS loader here. Now, we already installed TypeScript globally on our machine, which is why we are able to run tsc-w. Now, it is a good practice to also install a copy of TypeScript per project, so that for this project, you get a specific TypeScript version. The advantage is that if you ever change your global TypeScript version, you don't break your project version, your project setup, if there were breaking changes in TypeScript itself. So we can lock in a specific version of TypeScript for a project. That's why we install it separately here. And the TS loader now is a package which will work together with Webpack. The TS loader is a package that tells Webpack how to convert TypeScript code to JavaScript so that Webpack is able to do both. Compile our code with the help of TypeScript loader, which in turn, of course, uses the TypeScript compiler under the hood. And then Webpack also is able to bundle our emitted JavaScript files into a bundle.js file, into one bundled code file. Well, and with that, let's simply get started and let's set up a Webpack project so that we can use Webpack for all these nice things. To get started, let's first of all go to the tsconfig.json file, because there we need to make sure that certain things are configured. Make sure that target here is actually set to ES5 or ES6. That is up to you. It depends on which browsers you plan on supporting, because in the end, Webpack and the TypeScript loader will use this target to determine how your code should be transformed. Should your TypeScript code be transformed to JavaScript code that runs in older browsers as well? Or, as with ES6, to code that only runs in more recent browsers. Module then should be set to ES 2015 or ES6, so that setting is fine. And in addition, you also want to verify your output dir. I will keep it to dist, but you could change this if you want to compile your code to a different directory. You don't need the root directory anymore though, because Webpack will take over there and Webpack will determine where your root files are. So in general, these settings should be fine. We can always tweak them later if something doesn't work the way we want it to work. With that, let's add a new configuration file next to tsconfig, and that's the webpack.config.js file. And make sure you do really name it like this, because this is a file Webpack will automatically look for, and this will in the end tell Webpack how to work with our project, because Webpack is a tool which needs to be configured to work correctly here. So what do we do in this webpack.config file? This configuration file uses JavaScript, and actually it uses Node.js features. So we want to use the Node.js export syntax, which looks like this, to then export a JavaScript object, which will be the configuration object picked up by Webpack. So in case you never saw that before, this is how you export things in a Node.js environment. And here we are exporting a JavaScript object. Now Webpack needs a couple of pieces of information. Most importantly, it needs to know with which file your entire project starts, so where your entry point is. And in our case, that's the app.ts file. This file should be executed first, and what Webpack then will do is it will have a look at the imports in this file and go to these files and have a look at their imports and the imports of the imported files and so on, until it knows all files your project uses in the end. And then it will go through the file content, like this content here, and all the content in all the files, and compile them with the help of the TS loader package I mentioned. Now, to make Webpack work correctly here, you should actually now remove all the .js extensions in all the imports. We needed that before, when we used the native browser built-in ES module functionality. But with Webpack, you don't need these extensions, because Webpack will actually automatically look for .js and certain other extension files. So you don't and you shouldn't add them here. Otherwise, Webpack will look for files with a double extension, which you don't want. So remove .js on all these imports here. And once you did that, save all these files to make sure your, changes are applied. Now back to webpack.config.js. There you now should add an entry property in this exported object and point at ./source/app.ts in our example, so at the root entry file of your project. Next, add an output key here. An output now actually is an object here where we first of all specify the file name. This will be the single JavaScript file which will be produced in the end. And here we'll name it bundle.js, but you could name it whatever you want. App.js or whatever, well, whatever you want. You can also add dynamic parts here, for example, content hash, to tell Webpack to automatically create a unique hash for every build, which can help you with caching in the browser. But again, you can learn more about that in the Webpack docs. Here we don't need that, so we'll just name the file bundle.js. In addition to the file name, you also need to specify the path where the output should be written to. And of course, that should match the path you have in your tsconfig.js JSON file to avoid errors, so the dist folder. Now, unlike in the tsconfig.json file, you shouldn't write /dist here. Webpack wants an absolute path here, and to build one, we can use a Node.js module. For that, we can use the Node.js import syntax, which uses the require keyword, and import the path module. You don't need to install this as a library. This is a core Node.js module, which you already have if you got Node.js installed, which you do because we did that earlier in the course. Now you can use path to call the resolve method there, which allows you to build an absolute path to a certain folder. For that, we use a special constant, the __dir name constant, which is available globally in a Node.js environment. And Webpack, as I said, uses Node.js to execute your files. And then, as a second argument, dist. In the end, dist just constructs an absolute path to the dist folder, which Webpack then uses to write your output there. Well, and with that, you got an entry point and an output point, but you don't tell Webpack what to do with your TypeScript files. Because by default, Webpack doesn't know that. By default, it's just a bundler. Any extra functionality, like compiling TypeScript to JavaScript, has to be taught to Webpack. We'll do that in the next lecture. So to tell Webpack what to do with TypeScript files, we need to add a new entry to the configuration object here. And that's the module property. Module also takes a JavaScript object to then configure it. A module in the end is just a file. So here we tell Webpack how to work with the files it finds, like with the app.ts file, and then also once it understands that file, how to deal with all the imports in that file. So how should Webpack deal with these files? Well, we tell Webpack by adding a rules array here, because you can set up multiple rules that should be applied to all the files. Here we only need one, but in more complex projects where you also want to use Webpack to handle CSS files or images or anything like that, you can add more rules for different types of files. And as mentioned before, the official docs are a great place to learn more about loaders, which you in the end use to teach Webpack more about different files, and to learn more about Webpack in general. So here we will add such a loader actually. A loader is simply a package that tells Webpack how to deal with certain files. And of course here we got the TS loader, which helps us tell Webpack how to deal with TypeScript files. So we add a rule, which is just a JavaScript object, where we first of all add a test property. This describes a test Webpack will perform on any file it finds to find out whether this rule here applies to that file or not. And the test here is a regular expression. And there I want to tell Webpack that any file which ends with .ts should be used or should be handled by this rule. A regular expression that checks for the file extension can use a backslash here and then .ts and then a $sign. This is a regular expression which in the end tells Webpack that you want to check for files that end with .ts. Then you also have to specify what Webpack should do with those files, and you do that with the use keyword here. And there you specify the loader Webpack should use, in my case ts-loader. So we tell Webpack that any TypeScript file it finds should be handled by the TypeScript loader, which then in turn knows what to do with such a file. The ts loader will automatically take the tsconfig.json file into account. So we don't need to specify any extra configuration here. Just one configuration that never hurts: exclude node modules as a regular expression, so that Webpack also doesn't try to look into node modules. With that, we need to add one extra configuration here after the module configuration, and that's the resolve key. There we tell Webpack which file extensions it adds to the imports it finds. I said Webpack would add extensions on its own, and by default, it will look for .js files. Now here we want Webpack to look for .ts files, and therefore here in resolve, we can add an extensions property, set this equal to an array, and tell Webpack that it should look for .ts files as well as .js files. So now Webpack will basically look for such files and then bundle all files that have these extensions which you are importing together. And that's our setup almost finished for the moment, our configuration file almost finished for the moment at least. With that, we just should go to tsconfig as well, and there make sure that you set source map to true. This will help us debug our code, and Webpack supports this as well. There we now just also have to add an entry, maybe here below output, and that's the DevTool key. And there the value should be inline-source map as a string. This in the end tells Webpack that there will be generated source maps already, which it should extract and basically wire up correctly to the bundle it generates, so that whilst we get such a bundle, we still have a great development experience. Now with that we can use Webpack, and the question is, how do we use it? A simple way of using it is to go to the package.json file, and there let's add a script. For example, build. You can give it any name you want here in the scripts section. And there, simply run Webpack. So just type Webpack like this. Let's now also go to the dist folder, and in the end remove everything that's in there. And with that, save it, and now run npm run build, and let's see whether that works. And it fails. Yep, I simply got a typo. That should not be DevTools, but DevTool here. So change this to DevTool in the configuration file, and now let's repeat npm run build. And with that, you can ignore the warning you get here. You will see that in the dist file, you have a bundle.js file. And what you see in there also already is quite unreadable code, because we have this minification in action here actually. So this actually already is this optimized code as well. Now before we see how we can also work with different configurations here, let's actually go to the index.html file and adjust our import here and point at bundle.js. And for the moment, since we're not using Webpack Dev Server yet, let's run npm start to bring up that index.html file again. And if you now reload this page, you see this works. If we enter something here, our project works the way it should. And it imports the bundle.js file here, so only one file instead of all these individual files. And that already is an enhancement. Here we already have that bundle code, which avoids all these unnecessary HTTP requests. And if you go to the sources tab, by the way, and you want to debug your code, you will find this Webpack folder, and in there a source folder, and there you can go to your TypeScript files. And for example, here on project input, you can also set a breakpoint here on gather user input, and if you now press the button, it pauses there, and you can debug your code. And that's the source maps coming in, which really help us developing and which make our life as a developer easier. We got this optimized code, but thanks to the source maps, we can debug our original TypeScript code here. So we already have a pretty amazing setup, which gives us a lot of optimizations already. Now let's finish this and make sure we actually have the Webpack Dev Server included, and we then actually have two workflows, one for production and one for development. At the moment, I'm not using the Webpack Dev Server. Now server it is very straightforward though. We just have to go to the package.json file, and now there, instead of light server, let's use Webpack-dev server, like this. And now let's start npm start again. Now what you'll see is that this now spins up a server running on localhost 8080, and it spins up the Webpack build workflow. So if we now visit localhost 8080, we see our project there. The interesting thing now is, if we change something in code, for example, if I just add a console log here, and I save this and you watch the bottom here, you see it recompiles. However, if you reload, You don't see the log here, and also in the sources tab, in the webpack source tab, if you go to app.ts, you don't see the log here. So it actually did not load the correct code. This becomes clearer if I delete this bundle.js file here. If I now restart this npm start process, you will see it still works. And by the way, don't wonder that the dist folder stays empty now. In the Webpack dev server mode, the bundle is generated in memory only. So it is there and it is loaded by the dev server, but it's not actually written to the disk. But you'll see that if you reload, this page now also crashes. Now I said the file would be there, but it doesn't seem like it's there, right? Now it's missing on the disk, as I said, and of course we are importing from dist bundle.js in index.html, but indeed, you can believe me, it is generated in memory. The problem just is, things are not wired up correctly at the moment. To tweak this, we have to go to the webpack.config.js file, and there, in output, actually add a public path key and set this to dist. If you now save this and restart, now you see it reloads, and now you see hi here. In the sources tab, you now also see that correct output there. If you go to the dot folder, source app.ts, you see the console log statement. And if I now go to app.ts and delete that, it rebuilds, and now the console log statement is gone there. This is just an additional configuration that is needed for the Webpack dev server to really understand where the output is written to and where this is relative to the index.html file. Because by default, the Webpack dev server serves an index.html file it finds in the same folder as you run this script here, which is correct. But then it doesn't make the connection to the dist folder correctly, which is why we have to inform Webpack dev server with public path where to find our assets, so our bundle.js file in this case. Now, if we quit the development server, there is one other setting I want to apply here in development mode. And I'll do this right at the top of the exported object. I'll set mode to development. This will in the end tell Webpack that here we're building for development and that it will do fewer optimizations to improve our development experience, make debugging even easier, and give us more meaningful error messages, for example. So in development, we also definitely want to add this key here. And with that and the Webpack dev server configured, we now get the finished development workflow. Now for production, we'll need to adjust this workflow a bit because there we want a different output. We prepared our development workflow for Webpack here, configuring it for the Webpack dev server, setting the mode to development, and setting up source maps to improve our debugging experience, to give us better error messages, and so on. Now, for production, so when we want to prepare our code to upload it to a server, where it then will be served to our end users, we typically want a different workflow. And therefore, I'll add a new config file, webpack.config.prod.js. This name is now up to you because Webpack will not look for it by default. We'll tell it to look for it in a second though. Before we tell it, let's actually copy all the development setup here over to this config.prod file. But now let's fine-tune it. We can set mode to production, for example. This will tell Webpack to do these optimizations, minify our code, and so on. So you definitely want to set this here. We'll leave entry. In output, we can get rid of the public path because that was required for the Webpack dev server. Now we will not use it here because for production, we want to run the Webpack script and generate our output written to disk and not served temporarily on a locally running server. We can set dev tool to none to not generate any source maps here because in production, we might not need them. Now the rest can stay as it is, but we will add more. At the bottom here, I want to add a plugins entry and set this to an array. Plugins are extra, extensions or, plugins you can add to your Webpack workflow, which will basically be applied to the entire output, to the entire project. Rules and modules specifically are applied on a per file level. Plugins are applied to the general workflow. Here, I want to add a plugin which automatically deletes everything in the dist folder before new output is written there, so that we always just have the latest, most recent output in the dist folder. For that, I'll install a brand new package with dash dash save dev, and that's the clean dash webpack dash plugin. And this will help us clean up the dist folder in our case whenever we rebuild our project. So with that installed, let's import it here at the top. I'll name it clean plugin and import it via require clean dash webpack dash plugin. And with it installed in the plugins array at the bottom, we just call new clean plugin dot clean webpack plugin and instantiate this. This is a constructor function, and now we instantiate it. This is all you need to do here. And this will in the end tell Webpack that before it writes something to this output folder, it will clear everything that is in there. Now we got the finished production workflow. Now to use it, let's go to package.json, and there let's adjust this build script. Here I want to tell Webpack to use this prod file, this production configuration file. And we do so by adding dash dash config and then webpack.config.prod.js here. This here should be whichever file name you chose, and this instructs Webpack to use this configuration file instead of the default webpack.config.js file it normally looks for. And with that, if you now run npm run build, it will build your app for production, which means it gives you this optimized output. So if you wait, here we get the bundle.js file, and this is now really the optimized code built for production, and this, together with your index.html file and the app.css file, is what you would put onto a server here if you want to deploy your application. This is also the end of this module. Now let me sum up what we learned. So we added Webpack, a very important tool that allows us to bundle together our different files into one bundle. This really helps us decrease the amount of HTTP requests made and therefore can speed up our application. If you find yourself working with a lot of individual files, which you typically do in bigger projects, tools like Webpack are a must use. And Webpack is the most important and prominent tool that helps you with that, so therefore it's the tool I wanted to show here. You see that Webpack is highly configurable, and as I mentioned multiple times, the official docs of Webpack are the place to go to learn all about it, about different loaders, different other settings you can set up, and how it works in general. So definitely dive into this documentation if you want to become a Webpack master and you want to have a more elaborate setup. Our basic setup here, however, already allows us to compile TypeScript files with Webpack and then bundle together all the output into one single bundle.js file. And we also set up a configuration for development, which makes debugging easier and gives us more helpful error messages. And we get a production setup, which gives us a highly optimized code, which we then could deploy to a server to ship as little code as possible to it. And that's it. Webpack really is a core tool, and being able to use it and having a configuration that really just works is super important. So it is a must use in any modern project, I would say, and in this module you learned how you can get started with it in your TypeScript projects.